Hello, this video is part one in the series of videos that I've created on organic chemistry fundamentals. In the first video, we're just going to look into the type of formulas that are used to represent organic compounds. Organic chemistry is the chemistry of carbon compounds. So you will be just literally studying compounds that are made up of carbon along with hydrogen and oxygen or some other elements. But predominantly you will have carbon in organic compounds. Why carbon? What is so special about carbon that makes it to create its own branch of chemistry? So if you look at carbon, carbon's made up of 6C12, so it's made up of 6 protons and 6 neutrons. So in the middle, the nucleus, you would have 6p6n. It has got 6 electrons. That means it will have 2 shells. Got 666. So this is devil incarnate. So you've got, that was my pathetic attempt for 666. So it's because carbon is so devilish that it can do variety of things. It can form long chains. It can form incredibly long chains. It can form circles. It can form cyclic chains. So carbon can do branch chains. No other element in the whole of the periodic table can do as many weird things in terms of joining up as carbon. And it's because of this property that carbon can form incredibly huge amount of compounds, and it's formed so many compounds with itself joining with other elements that you end up having to study a branch of chemistry devoted to carbon. So carbon is, it can be your best friend because in fact you are made up of carbon as well. So all organic material is carbon. So let's look into the carbon chemistry. So jokes aside, carbon has got covalent bonding. We've just seen that carbon's got 4 electrons in its last shell. So that means it needs 4 more electrons to become 8. So if I bond it with hydrogen, you will see that each hydrogen has got 1 electron in its last shell. So each hydrogen atom shares 1 electron with carbon. So overall, you have got carbon surrounded by 4 hydrogens. And if I just show it like that, you've got 4 bonds around carbon. So carbon forms 4 covalent bonds around itself. So every time you do write the formula, you've got to count around carbon. You should have 4 single lines. Okay, so when you look into the formulae, we're going to look into variety of formulas, and every time you do the formula, you've got to count how many bonds around carbon. Carbon should have 4 lines around it. Functional group is a group of atoms that are responsible for a certain type of reactions of a molecule. So an alcohol will have an all-alcoholic functional group. We'll do a lot more on functional groups when we look into the nomenclature and the naming of organic compounds. So you've got alcohol, carboxylic acid, aldehyde. So some of examples are here. Now we move on to the type of formulae. So we're going to decode each of these formulae and we'll look into some examples. So molecular formula is something that gives you the actual number of atoms of each element in the molecule. So some of the examples, so C2H6 will tell you exactly that this compound has got 2 carbons and 6 hydrogen atoms. You can simplify it by dividing it by 2. So C2H6, if I write it in the simplified manner, I'll get CH3 because the ratio 2:6 can be simplified to 1:3 by dividing it by 2. So the simplified ratio that you've got, So the simplified formula is called empirical formula. So empirical formula gives you the simplest whole number ratio of atoms of each element in a compound. Structural formula, it will show you the atoms carbon by carbon with the attached hydrogen functional group. So ethane would look like this. You just write CH3, CH3. So that's your structural formula. And if you have to show displayed formula, so if CH3 was your structural formula, to display the formula, that means you've got to show the bonds around it. So you got to open the structure up and you got to show the bonds around it. Same way, pent1-ene, when you open it up, you show the bonds. So displayed formulas are a better way if you are trying to show the reactions and if you want to see exactly where the double bond is, or if you are showing mechanisms, it's best to use the displayed formula. So these are some examples of how to write displayed formula. General formula. In organic chemistry, when you study different types of compounds, so if you're studying alcohol, you have alcohols behaving similarly. So you will have some kind of a general formula representing an alcohol. Now this formula is representative of alkane. So if the value of N is 1, I would say C1 H2 times 1 plus 2. That means CH, 2 times 1 is 2, 2 plus 2 is 4. So that is a formula of alkane. So you can use this formula to find out the molecular formula of any compound in that particular series. So general formula, I will be going over them when I post videos on different functional groups. I've already done a video on alcohol. You might want to look at that. So alcohol general formula is CnH2n plus 1 OH, because alcoholic functional group is OH. So if N is equal to 2, so C2H2 times 2 plus 1 OH. So you'll have C2, 4 plus 1 is 5, C2H5 OH is the alcohol with 2 carbon, and we know that's ethanol. Skeletal formula. So in order to figure out the skeletal formula, you would need to know the formula of the displayed formula of the compound. So let's say we're looking into a compound that is this. So if I go CC4, 5, so I've got, if I put F here and if I put F here, so each carbon, as I said at the start, each carbon should have 4 bonds. So if you hide other carbons and if you check for each individual carbon, it should be surrounded by 4 bonds. So that's your displayed formula. If you're showing the skeletal formula, you only show the carbon atoms. So if I count the carbon atoms, so you only show the bonds of the carbon skeleton. So if I look at the carbon skeleton here, I've got 5 carbons. So it's shown in a zigzag manner. So the carbon bonds, if I 1, 2. So if you look at, I'm going to put a dot here just to make it clear. 1, 2, 3. Each dot represents a carbon atom in that skeleton. So I've got 5 here. I'm going to put them in this order. 1, 2, 3. 1, 2, 3, 4, 5. So I've got 5 carbon like that. So you would just do. So now you know what these dots mean. So this is how you show the skeletal formula. So this was 1, 2, 3, 4, 5. But in this structure, I have got an F fluorine atom attached to the first and the 5th carbon. So here I've got one fluorine attached and another fluorine attached. So now I would go to my skeletal formula and write F and F. So I'm allowed to show any functional groups that are attached. Now, if there was a double bond in the compound, so if I had 1, 2, 3, 4, I put a double bond there. So 1, 2, 3, 4, 4 bonds around the first carbon. Let's see how many bonds. 1, 2, 3, 4 around the second carbon. Let's try out around third carbon. 1, 2, 3, 4, 1, 2, 3, 4. So I've got 4 carbons. So again, 1, 2, 3, 4. So I'll just draw the skeletal formula once I've figured out how many zigzag lines to draw. I've done that. Now I know 1, 2, 3, 4. Between the first and second, I've got a double line. So I'll just draw the double line there. So that is how you draw your skeletal formula. So in skeletal formula, you only show the bonds of the carbon skeleton only. And if there's any functional group, you would put the functional group on that particular carbon. So in a nutshell, what we've looked into is we've checked out the looked into molecular formulae. Structural formula is, so if I have got molecular formula C2H6, my structural formula is CH3, CH3. The displayed formula is whereby I show the bonds. I write it like that. I show all the bonding there. Empirical formula is when I simplify. So C2H6, when I simplify it, I can write CH3. The general formula for that is CnH2n plus 2 because it's an skeletal formula means I'll just use that displayed formula and I'm going to decode that. So I've got 2 carbon there, so I can just use 1 line. So that's my skeletal formula of alkanes. So I hope you've understood this topic and I'll look forward to seeing you at my next video. So thank you for listening and watching. Thank you.